Guys, back more again. It's N6 Mechanotechnics. So we have here, this is an example 8. A train with a mass, you've given the mass in tons of the train is traveling down the incline of that. You've given the incline at the speed of this 54 kilometers per hour. Dot. Then we have the combined truck. We have seen the combined truck and rolling resistance is that is combined truck and rolling resistance is for combine. Read it carefully there. Combine, not singular, but combine. Anyways, are we together there? Well, fine. We've given that is 125. When the brakes are suddenly applied, when we apply the brake, suddenly applied the brake, the train the train brought uniformly to rest over this distance. Brought uniform to rest. So we have, this is the final velocity. We have two velocities. So we have average speed. We'll have average speed there over this distance. So says now calculate here A, the additional total resistance applied to the track due to the brakes. Remember, here it is, you incline. If you have your locomotive, if you have a locomotive there, let's say it's pulling some trucks. Let me just write two, let me just say 3 anyways. So when, remember this, between here we'll have the rolling resistance that is acting in the opposite direction. But when you brake, will increase. Already there's a rolling resistance, but when you brake, you'll make it more. Now you will increase the rolling resistance. You increase now the friction. You're supposed to go up now. Will increase. Remember, when you're braking, we want that rolling resistance. When you are braking, when you just brake, remember, remember even the car, when the car is moving, even though it's moving, there's a friction, but that friction is less. But when you brake, like, the brake will increase. The brake increase what friction, they'll make the friction to increase there. I hope you understand. That is why you'll hear sound when the car is at rush, when it's braking. That it shows that now you're increasing the friction there. It's making what noise. We took it. So we want that. We want to calculate that additional friction that will caused by when you're applying the, what we call this, when you're applying the brakes. It's fun. N5, if you still remember, when you're applying brakes, you must know that TE, I'm applying brakes now. When you're applying brakes, we call TE, or you can say T brake, but we know, man, it's just T. Call it TE, even though we know it's T brake. But okay, let me just say T brake. Maybe it will say not me brake. Maybe it will satisfy you there. Let me, maybe you wanted to call it, but I know that it's TE. You must know that now when we are stopping, the moment you stop, right, there will be instantaneously, remember, DJ, let me not roll tracks now. Remember, let me just say roller coaster or anything. Let me just say, okay, let me just do that track there. Anyways, oh, that guy is bad at that drawing. So going down, as I'm going down, I will have F. I have FG, obvious, always acting the NTE. Then we know this side will have our FR and FA. You must know that the moment I'm braking, always know that when you brake, the gravity, the first two acceleration, I want to say that the first two to acceleration, the first when I'm braking, the first two acceleration, there will be an instant. This car will, when you are braking, this car is forcing to go. Is when you are braking, let's say you're going forward. When you brake, you want to come to stop. In other words, the car is trying, like, let me just say naturally. Let me just say naturally. When you're braking, there will be some force. You will try like to go backwards a little bit. So FA will be instant. At that instant, brake will just point in that direction. Instant of that brake will just change it. When during the brake will be just an instant of changing of FA. We will have that only. We'll have an instant. It will be an instant there that will take place like that. You'll have there an instant that will take place at that portion. The instant. And it is fun. This is what you suppose you it's fun. You have to know that it's fun. There will be that instant there that will take there. So these guys, they will be related. Let me say, now these two guys, now they will point in the same direction from that instant. And then also that instant TE, it's for when you're during break. Take note, TE will replace FA. Instant will act also in the opposite direction again. I know FR and TE cannot act in the same time, but during the break, that instant time, during the break, that instant time, you must know that they will swipe. FA and TE, they will, natural physics, it's just the physics that will take place. So physicists, they just saw that, and they've seen that if you do that at the instant, there will be, that is why when the ball, you throw it upwards, at that instant, the maximum, you'll find that the velocity there is equal to 0. There's just instant, they change, and then instant again will go back, will decrease again, things like that. But you see that instant, you understand, we'll have that. So will be fun. It's fun how it is when you have during just that break. So in any way, that means TE now. I can just say T break. Okay, T break now, so that there will be specific, so that you'll know I'm talking about T break. I don't know why I'm using T break. I don't know why I'm writing T break. T break, not break. T break. Let me not say equal. Let me, since we see that will be plus what here, you can see it's pointing on the same direction, plus FR, plus rolling resistance. I know it's fun. Plus this, they're pointing in the same direction. FG plus FA will be equals to this. I know it's fun, but this is what you're supposed to know. I know originally, if they were during no breaks, guys, during no breaks, I know. When we don't have breaks, I know, guys, that we'll have, if you have the slope, I know you'll have if your car is going there, let me just say, if the car is going down, we'll have TE, we know that. We'll have FG as always, we'll have FR, we'll have FA. During no break, the normal scenario. But during break, these twos, they will interchange TE and TA and FA and FA. They will interchange, they will simply swipe at that instant. All right. Anyway, that is it. That is it. they will swipe at that instant. Mine is during the break anyways. So it's because we should calculate what the total additional applied to the brake during that resistance. Because now a brake, we have to treat this the total that total rolling resistance. That total resistance is fun. We won't use, remember this is a resistance, will be equal the additional brake, that the additional rolling resistance will be equal to T brake. It will be equal to that additional. That additional is cost will be equals to this. Alright, so we want TE. If you want TE, T brake actually, let me just say T brake. So you'll goes to, if you transpose that to the other side, you'll have FG plus FA minus FR. So there it is. This is the equation you're supposed to use. So let us fill up. We know that is what we're supposed to use. So let us fill up what is needed. We need FG there. So FG, we know, guys, FG is equals to what? It's equals to mass multiplied by gravity multiplied by the incline slope multiplied by the slope. So about that. All right, but now is the multiplied by the slope. Well, I know that, but now there we have that. We have to multiply by that. I know you can calculate that. It's fine. All right. Let's check. What is the mass? Oh, sorry about that. Lumsy. What is the mass? All right. The mass there of the locomotive of yes is what? It's 550 tons. You can convert that. So let us convert that. If we convert that is what? Convert that, the mass is given by what? By tons. Remember, tons is the same as you multiply by 1000. You'll have 550. It's the same as you multiply by 1000. 1000 is the same as times 10 power of 9. Gravity is 9,81. The slope, what is the slope? The slope we've given there, it's 1. As you can see, it is 1 in 120. So you multiply by 1 in 120 over 120. So you have your gravity there. As you'll multiply there, you're supposed to get nicely your gravity 44963 Newton. That is what you'll have there. That is your gravity there. So we have the gravity. Good. We are done with this part. Let us go to FA. Accelerating force. Accelerating force. FA. Now we'll need to, FA will be equals to the mass. Remember, we want FA, the accelerating mass multiplied by, since it's acceleration multiplied by acceleration. Do we have acceleration? That is the limitation here. Do we have acceleration? No. How can you get acceleration? Using the motion formula. How? We've given initial velocity here. We've given the initial velocity 550 kilometers per hour. We've given the distance. We've given the final. This comes to rest. It's final. So we'll use the motion formulas to get acceleration. Remember, 2as is equals to v squared minus your initial velocity squared. If you want the acceleration, we divide there. Remember, acceleration is simply just v squared minus initial velocity squared divided by 2s, because we have, that is why I'm using this, because we have s. So acceleration, final velocity, we know this will be what? Will be 0. It must be negative. Obvious, it's accelerating, is going on, must be 0. The final is comes to stop is 0. What is the initial? What will be that initial? May I ask? what will be that initial? So we have 54 kilometers per hour, right? We have 54. Let me punch that. 54 divided by 3.6. So you divide this by 3.6. We have 15 meters per second. Obviously, we have to convert that. We have in kilometers per hour. So this will same as what? 15 squared divide by 2 multiply by s. What is our distance there? 140 meter. Multiply this by 140 times 140. Then I'll punch this. What will be the acceleration? Then accelerating, I'll get the negative value. Obvious, you're supposed either way. If you get positive, you are wrong. This thing is decelerating, must be negative 0.84. Obvious is in cubic meters per. Oh, cannot match at. Oh, sorry. Meters per second square. Meters per second squared. Obvious, it's acceleration. So this is what it's negative. So the accelerating force, remember the accelerating force when you are punching there, obvious you'll get your answer to be negative, but it's showing that it's an opposite, it has reversed. Okay, why is negative? So you understand it's supposed to be here to act like that, but now will be negative. It's showing that it has reversed. It's acting downwards in that direction. Is reversed. That is why we have swiped those things. But anyway, I'm not there. I'm not there. I'm here. We have the mass. We know will be 5 times 10 power of 3 multiply power acceleration 0.804. This our F, force of accelerating there. We'll have it 442200 Newton. Remember, we have your negative. You have your negative. It's negative this. However, we know it's just showing that it's decelerating. We know that it just shows that it's an decelerating. So you can just say therefore FA will be positive 44220, and it's just showing that it's a decelerating force, nothing major. You have now that, so we must go to FR. What will be FR? We know FR is mass multiplied by rolling resistance. The mass is 55 times 10. Remember, it's in ton. Okay, let me leave it in ton for now because it's 5. Let me not convert to kgs because I have 120 Newton per ton. It's in ton. So be careful. Why here I have multiplied by this? So that will be in kgs. This is measured in kgs. This is the mass, is in kg. But now, also the mass here. Why here I will just substitute this in tons, because I'll say ton multiply by that. Remember, N, this is in multiply by Newton per. Remember there it's we have given the, we have ton, not we have tons, not newtons. Or we have tons. Either ways we'll have tons. The mass there is ton multiplied by this rolling resistance. We have as it's in Newton per ton. The aim is to calculate this, and this will cancel. We'll be left with newtons, which is good. Force is measured in newtons. So as you can see, that is why I will substitute this in ton. I won't convert that. Multiply by our rolling resistance. You've seen it's 125. So multiplying that, we get my rolling resistance 68750 Newton. That is the rolling resistance. So we have the rolling resistance. So we can find T brick now. We have this now. It's full. Everything now is full. I have all of those three now. We can find the T brick now. T brick. Alright, will be equals to what? Remember, will be the sum of all that. Will be this 44220 plus, let me add another one. We had plus this one, there must be 3 plus this one since we're adding here. So it'll be plus that we add plus 963 plus, yeah, because now you see, remember I said reduced thing will go, we have FG plus FR. I've talked about FG. Remember, this is the formula. Let me rewrite it there. We have FR, that will be FG plus will add. We'll have, I know why I'm doing, why I'm doing that, please. Remember, this is the FA. We have FA there, remember, minus our rolling stuff, rolling resistant lap there. So simply must be careful when I'm adding. I'll add FG, it's here, FG it's where it's here, 44963, 44963 plus the accelerating force, it's here, that is it, 4422 minus the rolling. The rolling is 68750, 68750. So okay, punching that, therefore, sorry about that, therefore tip brake will be equals to what? You'll see this will be 418,413, obviously must be Newton. So this is what we have obtained. Actually, this is what we have obtained, what is needed. So we are done with this. TE. B, what do they want? That was A. B, they want the total rate of dissipation of energy at the stand the brake applied. You want the instant. Over here, obviously, must be instant. The brake, the total there, it's an instant. It must be an instant, even the one that we've calculated. TA, we know it's an instant brake force at the instant. So we want B at the instant. Want dissipated what here? The total rate dissipated energy. Okay, it's energy. We need energy. Energy is measured in joules. It's in joules. It's a work. Energy, guys, work is measured in joules. We're talking about work done. What will be that work done? Taken by that work, power dissipated, or you can say energy, obviously must be in joules. So, or you can say energy dissipated, as they say, energy consumed, dissipation, or that we know. All right, we know that work is force. What about that alarm? Work is force multiplied by the distance, that is work. All right, that would be work. The work is that. So the work will be that. The force from that, we have the TE of the brake. All right, let me go. We return back to my structure. We have TE there. Just the instant, the power dissipated. Remember, they want the power. You must be note. There will be power that will be caused when it's braking. That will be T brake here. Plus now also there will be the power as is braking. The gravity is trying to put it down. It will add, will consume, will cost more of the power that will take place there. We'll have just add also the gravity. I don't know how you will comprehend this, but is what it is. You add multiply this by the distance traveled, not just the distance traveled before it reached, until where it reached that stop at the instant that distance traveled. We have TE. Here it is 814 is 481. Here it is there. You can see the anyways 418 413 418 413 plus the gravity we calculated here on the top. FG corresponds, where is my FG? FG, but if I can say, let me check. Never. FG can never. You did. FG can never. Can never. Because now it's a braking instant. It's acting here in this direction. Never. It's acting in this direction. Never. FG. No, I'm wrong. Because T is acting in this direction. Also FR. FR is acting there. Remember, it's an instant brake. So you will be affected by this and by rolling resistance, and by rolling, that it's incorrect. Sorry guys, can never that is incorrect. From my it's good that I've checked that structure where nav must be plus. I mean, it's a brake plus the rolling resistance is trying to stop the car. Yeah, will be affected by 2. This will increase in what? The rolling resistance. TE is increasing the rolling resistance is always there. It's trying to brake. Also, it will cause the heat dissipated. It's acting in that opposite direction. But because why I'm saying why I don't use that gravity, it's just that I've realized that the car is going down. The gravity is actually trying to pull it down. It's accelerating it because obviously it was also moving this direction. So the brake will try to pull it that way, will cause the friction to increase as the rolling resistance will act now I see. So we'll add that which we're supposed to add. So is that 68750 from there, 68750 times the distance. Obviously we know it was 140. I still remember that. Then punching this, it was 140. I still remember. It's simple. When I'm calculating here, it was 150 when I was calculating the acceleration thing. Then so this will be 68 just will have a huge number. This will be huge. Yeah, if I press scientific engine will be, I'll use this. Let me just use megajoules. You simply just use say huge. Let me use megajoules because obviously its energy is measured in joules. Check note. Remember, Newton times meter, it's the same as joules. Take note. We must know that. If you have not known that, it's the same as joules. That is why work is that. It's joules. Also, you must know joules per second. It's the same as watt as watts. Things that you're supposed to watch for. Alright, so that is it in this video. Thank you guys for watching. Do not forget to subscribe, become the part of the family. Stay tuned and feel free to share, feel free to comment, feel free. Right guys, feel at home, just then subscribe there. Let us grow together.